Welcome to Learning Progression 8, Creating Graphs. I'm Elise Naramore. So this practice is walking you through creating a graph that represents a particular scientific relationship. And we're going to be using graph features. I want you to be able to label the axes, scale the axes correctly, create a trend line that represents that relationship, and possibly write the mathematical model for it. Again, you want to know the common graph shapes. It will make your life so much easier if you know the name of the relationship and what the equation looks like and what the actual graph shape is. Here is the rubric that we've been using and that we will continue to use. So what I want you to do is I want you to think about where you're currently at, what level are you at, and then you're going to watch this video until you get to the next level, which is your target, okay? And then you're going to pause the video and skip to the strategies later on, because I don't really want you to watch the levels that are above where you're aiming for, because that can be a little overwhelming. So feel free to pause, skip, and then you'll come back to this video when you've achieved that next level and work on the one after that. We're just always learning and growing in this class. Beginning level means you create a graph. It means you label the axis with the variable names. You just sketch a line. It may be wrong. The axis labels may be wrong, but you did something. You tried. Developing levels, now it's relevant. You're not just trying, you're actually creating a graph that has relevant axis labels, and you have units with those axis labels. So by axis labels, I mean it's velocity, or it's energy, or it's spring force, or whatever the variable might be. So you're going to put that on there, and you draw a trend line. Doesn't have to be right, but it has to be present. Proficient means that the graph axes are now labeled correctly. The units are correct, right? And now you're putting reference values on both axes, right? Reference values, I mean, I'm putting either numbers, because you have them. So maybe it's 1 and 2 and 3 and 4, or maybe it's 2, 4, 6, 8, or 10, 12, whatever. So you've got numbers on both axes, and next to the graph, you state the relationship in words or with an equation. So if you're going to say there's a direct relationship between distance and time, you can write that, or you can put an equation where you write d equals something times t, okay? The shape of your trend line, if you draw a direct relationship, then and it matches what you stated because you said it was a direct relationship, that's proficient. Even if it isn't actually supposed to be direct. Maybe it was supposed to be a quadratic relationship. I don't care, as long as your shape matches what you say it should be. Then you made a mistake, we can fix that. All previous descriptors are met, but now the shape of the trend line is correct. You state the relationship, and that's correct. The scaled values are correct. And then sometimes we have graphs that have multiple lines or multiple sections to a line. So there's, an up and then a horizontal and another up, something like that, multiple sections. So you need to be consistent in terms of scale and slopes. So, if one line is supposed to be steeper than the other, then you're showing that clearly. If you have enough information, you're going to generate the equation of the trend line. It may be wrong, but you have to generate it. Expert is where the equation of the trend line is correct or the mathematical model is correct. You draw the right graph, even when the situation is complicated or unfamiliar. Complicated might be it's linearized, right? Or it might be unfamiliar as in we're playing around with a concept you haven't done before. So, you'd need some other information there, but I'll show you an example. If I ask you a part of the question about I changed this, how will it change your graph? That part is right. So that's extending it out a little bit. Here's your strategy. Please make sure you read the problem. circle or highlight the variables that are mentioned. Those are the things that are going to go on your axes. So make sure you know which variable you are changing. That's the one that goes on the X. And the variable that's being measured as a result of those changes, that goes on the Y. If you get those wrong, you can't get proficient. So you have to understand that part. Complete your problem-solving setup to fully understand. That means draw a label diagram, generate an equation. You might have done that in an earlier part of the problem on a test. Sometimes I pair these two together. So there's the learning progression 6 where you solve the problem, and then you can use that equation and the setup that you did in that to then inform your graph. Write the equation that connects the two variables, either from the derivation on another problem or just from the equation sheet. Rearrange the equation if you need to so that the equation and your variables mirror each other. And then use your knowledge of common graph shapes, that's where it comes in handy, to sketch that trend line. And then just say it. Since the equation is direct, I drew a straight line. You could say that. Put at least 2 points on each axis. If you know the actual values, scale them correctly. If you don't know the values, you can actually just use placeholders. You can put, kinetic energy 1 and time 1, for example. And then you can, if you can, write the equation of the trend line and or the mathematical model. Of a simple harmonic oscillator is the time it takes for one complete vibration. The period t depends on the mass as well as the spring force constant as shown in the equation above. A block moving with simple harmonic motion has a period of 2 seconds. The maximum displacement from equilibrium in any direction is 5 centimeters. Draw a graph of period versus mass for the simple harmonic oscillator. So let's do it. We're going to start by labeling the axes. So let's draw them. And what I've noticed is that we need to draw a graph of period versus mass. So period is on the y and mass is on the x, especially if they don't tell you what's being varied. You can assume that it's y versus x, like in the name. So this will be the period. The units for period are in seconds. And mass is here, it's in kilograms. So now let's take a look at this equation. Period equals 2 pi square root of mass over k. So if you look at the, you can't see that. If we look at these, we've got period here and mass is here under the square root. So period is proportional to the square root of mass. Again, this is where it becomes super useful to know the common graph shapes. A square root relationship looks like an eyebrow, right? It looks like that. So you can just write that. You can say there is a square root relationship. Or you could say a direct square root relationship between period and mass. Okay, so you've overtly stated the relationship, you've shown the equation, we've drawn the correct shape, and we've labeled the axes. So now the last thing we really need to work on is scaling the axes. So there's a few different ways you can do this. You could start just by picking up, you could be like, oh, well, here's 0, 0, because when this is 0, I know I'm going to have 0 period, right? So you can use that as a point. You can also pick another point. You could be like, okay, this here is going to be mass 1, and it's going to go with this point here, which is period 1. So that would be just like placeholders. But in this particular problem, they give you one of the periods. So if I put in, do they give you? Yeah, and they don't tell you the spring force constant. So how you can do it also, by the way, is you could take the equation And you could say that this is 2.0 is the period. And you can get an expression. You can rearrange this. And I'm going to square both sides. So I'm going to throw that into my calculator. So 2 divided by pi, by 2 pi is just 1 over pi. So I can do 1 over pi. Oops. And then square that. That comes out to be 0.1013, and that's going to be m over k. So 0.1013 k is the mass, right, when the period is 2.0 seconds. So so I can actually mark that point somewhere. So I don't care where you do it. Let's pick a point. You could be like, okay, I'm going to make this 2 seconds. And then this point here is going to be, what did I say, 0.10 k. And you can do it like that. So even if you're not given what the spring force constant is, you can still get an expression for it that shows that you know how to figure it out, even though you're not quite given enough information to solve for it. If you're going to scale, if you're going to make this 2, you should make sure if this is 1, 2, 3, 4, 5, 6, 7, 8, so then 4, this will be 1.0. So you should scale the axis appropriately. And then maybe instead of having m, and this is 4, that'll be 4. So instead of using that, I might do, this would be 0.20 k, right? So you can actually scale the axes, even when you don't have full numbers. Those are all things that you can do.